Types of Chemical Reactions Part 2. In Part 1 we discussed the different types of chemical reactions. Under the nature of rearrangement of atoms we discussed combination reactions and decomposition reactions. Now we will discuss the remaining types: single displacement reactions, double displacement reactions and combustion reactions. Single displacement reactions. Reaction between an element and a compound. Element of the reactant compound is replaced with reactant element to form a new compound and an element. Schematic representation of single displacement reactions. Take element A reacts with compound BC. The element A displaces element B and forms the compound AC and element B. Example. Let we take the zinc metal element in reaction with hydrochloric acid. Hydrogen is displaced by zinc metal and forms the zinc chloride and hydrogen gas. Another example is ferrous metal element in reaction with copper sulfate. Iron displaces the copper from its aqueous solution and forms the ferrous sulfate and copper. This can be observed by keeping an iron nail in a copper sulfate solution. The reaction results in the copper deposition on iron nail and the ferrous sulfate solution. Though similar kinds of reactions are proposed, it will not occur in practice. The feasibility of the displacement reaction is determined by the activity of the element and their position in periodic table. More active elements will readily displace the less active element from their aqueous solution. Let we consider the two reactions which is shown below. In the first reaction, fluorine displaces the chlorine from sodium chloride and forms the sodium fluoride and chlorine. Whereas in the second reaction it shows that the chlorine displaces the fluorine from sodium fluoride. But this reaction won't occur, since the fluorine is more active than chlorine. Also, it occupies upper position in the periodic table. Double displacement reactions. In this reaction, the ions are interchanged when two compounds react. Ion of one compound is replaced by ion of other compound. Ions with same charge will be interchanged, that is, cation will interchanged by cations, and hence it is called as metathesis reaction. In the double displacement reactions, one of the product must be a precipitate or water. Schematic representation of double displacement reactions. Compound AB reacts with compound CD. B displays the D and forms the product AD and BC. Further double displacement reactions are classified into precipitation reactions, neutralization reactions. Precipitation reactions. When two aqueous solution compounds are mixed together, reacts to form an insoluble compound and a soluble compound. The insoluble compound is the precipitate. When lead nitrate reacts with potassium iodide, potassium and lead displace or replace one another and forms the product lead iodide and potassium nitrate. Here the lead iodide is the precipitate formed in yellow color. Neutralization reactions. In this reaction the acid reacts with base to form a salt and water. The acid gets neutralized by base and hence it is called as neutralization reaction. Schematic representation of neutralization reactions. Acid reacts with base and forms the product salt and water. When sodium hydroxide reacts with hydrochloric acid, sodium and hydrogen displace or replace one another and forms the product sodium chloride and water. Another example is when ammonium hydroxide reacts with nitric acid. Ammonia and hydrogen displace or replace one another and forms the product ammonium nitrate and water. Combustion reactions. In this reaction, the reactant rapidly combines with oxygen to form one or more oxides and heat energy. It is also called as exothermic oxidation, since heat is evolved and oxygen is added. LPG, liquid petroleum gas, is a mixture of propane, butane, propylene, etc. Hydrocarbons burn with oxygen to form carbon dioxide and water. Propane reacts with oxygen and forms the product carbon dioxide, water with heat energy. Still, now we discussed the types of reactions under the nature of rearrangement of atoms. Now we discuss the types of reactions under the direction of the reaction. Based on the direction of reaction, the reactions are classified into reversible reactions, irreversible reactions. Reversible reactions. It is a reaction in which the products can be reversed back to the reactants. It is represented by a double arrow. Schematic representation of reversible reactions. Let we take a compound AB which decompose to form the product element A and element B in the forward reaction. The formed products element A and element B will combine together to form a compound AB. Let we take a compound phosphorus pentachloride decompose to form the product phosphorus trichloride and chlorine in the forward reaction. The formed products phosphorus trichloride and chlorine will combine together to form a compound phosphorus pentachloride. Initially, the forward reaction is faster than the backward reaction. Later it becomes equal, though the equation shows an equilibrium. The amount of phosphorus pentachloride is more than that of phosphorus trichloride and chlorine. Irreversible reactions. The reaction that cannot be reversed is called as irreversible reactions. Hence it is called as unidirectional reactions. Only forward reaction is possible. Let we take the solid coal which has the carbon in it. When it burns with oxygen, it forms the product carbon dioxide and heat. It is impossible to reverse the reaction. That is not possible to get the solid coal with the reaction of carbon dioxide and heat. We will meet in another topic. Thank you.